Okay, in this section of Chapter 10, we're going to be looking at the Calvin cycle and how we're using the Calvin cycle or the dark reactions to produce some sugars. So to start with, a little bit of overview about the Calvin cycle. To start with, it is building sugars, so it's an anabolic process, and it's using the ATP and NADPH from the previous parts of photosynthesis in order to drive this reaction. It is similar to the citric acid cycle. We have things entering the process or the cycle. We have things leaving it. What's leaving the Calvin cycle is G3P, glyceraldehyde 3-phosphate. It's a 3-phosphate or 3-carbon sugar. Notice that this is not exactly glucose. We need several of these to combine together to actually make glucose. So it's not glucose yet, but it is a sugar. It is a 3-carbon sugar. This is what is leaving the Calvin cycle. As you can see here, the cycle needs to go through a few times, 3 times, using molecules of CO2 in order to make 1 G3P. So it's not a quick cycle, so to speak. It has to go around several times just to make one of these things. Before we start looking at the process in greater detail, there's 3 steps to the Calvin cycle. The first is carbon fixation. The second is reduction, and then regeneration of RUBP, which is a carbon acceptor that is used in the process. So the first step of the Calvin cycle, we have carbon fixation. We can see on here RUBP, which was mentioned a moment ago, is a 1, 2, 3, 4, 5 carbon sugar. It's catalyzed by Rubisco right here, which you may have seen on the previous slide. And we take in some carbon dioxide. Looks like we have 3 carbons entering at one time. One of these carbons is going to plop onto RUBP, forming a new molecule that has 6 carbons. And we have the 5 and we have the 6 right here. This will be broken down into some 3-carbon sugars. And if you look right here, the 3's before it, and the 6's before it, and the 3's before it, that tells you how many of each molecule there are. So right here, there's 3 of these, so there's a total of 18 carbons right here. Each one of them has 6. Right here, there's 3 carbons, but there's 6 of them, so there's still 18 carbons. We need to be tracking these carbons as we move through the cycle. As we progress into the reduction phase, you'll see that ATP is being used, 6 molecules of it actually. Where is this ATP coming from? Well, keep in mind this is called the dark reactions, and it needs energy from the sunlight going back to the light reactions in order to drive it. So this energy was generated during the light reactions, and it has traveled into the stroma to drive the Calvin cycle here. So anyhow, we have these 3-carbon sugars, and they're being phosphorylated. We see 1 phosphate on this end, but down here there are 2. So we have phosphorylated these 6 3-carbon sugars. This forms 1,3-biphosphoglycerate. Once again, the 1 and the 3 refers to the positions of the bonds between these carbons and where they're actually bonded to. Thinking back to the glycosidic linkages, there was a 1,4 glycosidic linkage, and that referred to the position that a bond was held to between carbons, and this would be the same type of deal. By the way, you won't need to memorize these words. They might be used in some of the questions that you see on tests, quizzes, whatever. But you don't need to memorize these words. If you understand the process and understand these things right here, you can work around those words. I wouldn't learn them, to be frank with you. So don't worry about these big words. We need to understand the process, though. Anyhow, as we move forward, we can see that NADPH, once again from the light reactions, dropping off some hydrogens, keeping in mind that sugars have carbon, hydrogen, and oxygen. So we're getting some hydrogens as well as their electrons as we move through the chain, which is actually driving it towards a sugar, which sugars do need those hydrogens. So we're reducing them, we're donating some electrons, with those also some hydrogens. We can also see the phosphates on the left side being removed as we proceed through here, forming G3P, which is actually a sugar, and this is the sugar that will come out as we go through this process. And it will take several of these to kind of combine together to form glucose. The last thing we need to point on before moving to phase 3 is that we see 3 molecules of carbon dioxide going in. For every 3 molecules of carbon dioxide go in, we will make a total of 6 G3P molecules, or 6 carbon sugars. But only one of those 3 carbon sugars will actually leave the cycle for a net gain of usable sugar. So what happens to the remaining 5? The remaining 5 are used to make more RUBP. So 5 of the sugars, the G3P, stay in the cycle. So at this point we would have 5 times 3, we would have 15 carbons, whereas one step before we would have 6 times 3, we would have 18 carbons. So 1 3-carbon sugar left. So it looks like there's always a bare minimum of 15 carbons in this cycle. The carbons, 15 of those carbons are needed to reform RUBP, which can accept carbon dioxide as it comes in. So to sum up phase 3, quite simply, we have 3 carbon sugars, G3P. They're phosphorylated. We can see the addition of phosphates up here. There's one on each one of these, but now there's 2. And they are reorganized into 5 carbon compounds, RUBP, and there's now 3 of them. So 3 times 5 would be 15, 5 times 3, 15. So the amount of carbon stays the same. And to cap it off, RUBP can go in, accept more carbon dioxide with the catalyzation of the enzyme Rubisco, and the process continues. So as you can see, it seems like a lot of work just to make one small 3-carbon sugar.